Hello, and thank you for joining today's webinar. I'm Jordan Sloop, your host from Kentik Marketing. Our topic for today is how to monitor cloud services and why it matters. Our presenter is Michael Patterson, Kentik technologist, founder, and former CEO of Plixer. In today's webinar, Michael will review how to use synthetic monitoring to pinpoint sources of service outages and brownouts. He will also discuss why a distributed network of monitoring agents makes all the difference when troubleshooting network and application slowdowns. During the webinar, if you have any questions, please enter them in the Zoom chat and we will answer as many as we can in the open Q&A session at the end of the presentation. With that, I turn it over to you, Michael.
Thank you, Jordan. Hello, everyone. We have a great topic for you today on how to monitor cloud services using technologies that have really been around for years that, until now, haven't been retrofitted to work with the digital enterprise. Let's start with a question. What do you do when you are noticing that your application that requires the internet is getting slow? Well, many of us start clicking on things in our browser to see if they appear to be responding normally. But maybe you open another browser tab or a completely new browser and you go to a new website and you click some more. Basically, you're trying to figure out if other sites are responding like normal. And this is a pretty lousy test, but many of us do it anyway, including myself. And of course, maybe the situation gets worse because you start getting distracted. But once you refocus, maybe you remember that when troubleshooting a network, we should follow the rules of the OSI model. Then you think, nah, in this day and age, the problem is seldom the physical cables and usually not the Ethernet network. Perhaps you're familiar with the ping command. So you bring up a command prompt and launch a traceroute or start pinging the host names of business applications. This is also an attempt to find out if the problem is the application or your local internet connection, or worse, your laptop. Hey, maybe you even reboot your laptop as well. That's something I would try. Another one of the first things we do is ask our peers if they are experiencing problems with the same apps. If you're on-prem, this can be done over the cubicle wall, or if you're working from home, it might be done over a collaboration application like Slack. Well, what if your work area was actually a large office building containing thousands of others who work for the same company using the same cloud apps? And what if they're experiencing the same slowness as well? Something would obviously have to be done because it's going to end up costing the company a lot of money. So while the internet is just a network, the difficulty we face when troubleshooting cloud applications is that your in-house IT guys aren't able to get end-to-end visibility with traditional monitoring tools. This is because the SaaS apps that many of us are using could be hosted anywhere in the world. And if the problem isn't on-prem, it's somewhere between your office and the data center, and who knows where that is. Now, before we get into how to resolve this problem, we need to realize that there are a lot of ISPs involved with making cloud connections possible. And we know that sluggishness is going to happen once in a while when using our cloud services. But I'm talking about when reoccurring slowness isn't normal, and it starts to interfere with business operations. To take action on this type of problem, we need to confirm the consistency of the issue. Part of the problem is that the NetOps guys can't just telnet to the routers in the path and look at routing tables, and they can't span a port to collect packets. This all means that traditional tools won't provide the value they did when everything was on-prem. As a result, we have to get creative and come up with new tools to regain visibility into the applications we use that reside on networks we don't control. Although the problem could be with the end systems, we still have to consider that some service provider in the path across the internet could be causing the slowness. Thankfully, using tools like Traceroute, we can isolate the problem down to a specific router. With Traceroute, we can monitor cloud services on a hop-by-hop basis and build a baseline on the history of connectivity as well. If you've never seen a traceroute before, here's an example of a completed one. At the top, you can see I reached out to Beidou.com. Notice how it tests the response time to every router in the path 3 times. If we see an asterisk, that means we got no response. Each one of these IP addresses could be an ISP, and we need to find out who it is if they are consistently causing problems for our connections to cloud services. But even when we identify the service provider introducing the problem, what can you do about it? Well, we can call the service provider and explain the problem they are causing for the application. If that doesn't work, we'll need to figure out how to steer traffic around the service provider. Before we do that, we should confirm that we are facing a connection issue that is both reoccurring and excessive. To do this, we need to make sure that certain attributes involving a connection are being monitored. Otherwise, the troubleshooting process will be more difficult. Take a typical user, for example, who is trying to work with the SaaS applications. One of the first connections that has to be made from the user is to the DNS in order to look up the IP address of the domain such as Google Docs. The DNS could be located on-prem or in the cloud. Its location and response time can impact the perceived response time of the application. We need to be able to answer whether the slowness was introduced by the DNS or something in the path. Loaded with the IP address, the end system will then connect to the SaaS. Now, page load time can also impact the perceived response time of the application. Wow, let's summarize all of this. Was the slowness caused by the end system, the DNS, something in the path, the application, or the host the application resides on? These metrics, when collected from distributed locations, provide insight into how an application is performing for the entire company. So how do we get this data? Well, you might be thinking that putting agents on the end user's computers is one way, but with a workforce that's moving between the home office and possibly multiple other locations, the metrics fed back to the collection platform would skew the baseline if people were moving around all the time. Therefore, in many cases, separating the monitors from the end users makes the most sense. In order to monitor the cloud services and applications the business depends on, companies need a distributed network of stationary probes that can be used to monitor the applications from everywhere they have a significant user footprint. Now, maintaining the probes with all of the adds, moves, and changes can be very costly. This is often why we work with vendors. Companies like Kentik have already deployed hundreds of probes around the world called synthetic agents, which can be shared by their customers or privatized and used to monitor any cloud service from anywhere. The use of synthetic agents to verify performance is kind of like the example I used earlier of asking others if they are having the same issue with a particular app. A synthetic agent can be used to run a test that will, for example, generate traffic or time a transaction against just about any target at regular intervals. Targets can include hosts, applications, or even APIs. And this can be performed down to every second if necessary. And what are they measuring? Things like latency, packet loss, jitter, DNS resolution time, SSL negotiation time, page load time, and more. These details are all tracked over time and provide trends on availability, uptime, spikes, and more. Here's an example of monitoring a SaaS platform from over a dozen locations around the world. The icons in the map change color when the performance drops below a threshold in a specific region. Again, if necessary, these synthetic agents can pull applications as frequently as every second. If you click to view details on a specific agent, baseline details can be obtained. In this screen, we are seeing a trend of the HTTP stage breakdown. The data from the synthetic monitor is broken down by connection stage, which helps us determine more specifically where the latency is sourced. In this case, it was caused by the network as indicated in purple. Now, once the baseline is available, NetOps teams become aware of what acceptable patterns look like and can set thresholds if necessary. As stated earlier, these synthetic agents can be shared by Kentik customers or privatized. Under the hood, all of these synthetic agents could also be visualized like this. This map of both private and global agents is pretty much exactly how it's carried over into the actual product. The private and global agents can be deployed or activated anywhere in the world, and they run on multiple packages such as Debian, Ubuntu, RPM, Docker, and others. If you select a global agent, you can filter by autonomous system number, which allows you to test a digital service from multiple regions. And of course, you can also filter by public cloud provider as well. When adding a test, you simply have to think about what you want to test and then select a category. The steps to configure each test are pretty straightforward. Enter the URL of the digital service you want to monitor. Notice you can tell the agent to ping the device as well as perform a traceroute. I'll talk more about this in a few minutes. Select the agents you want to test from, enter a naming convention, punch in the parameters, select a notification, and if you need to, down at the bottom, you can select advanced options, which allows you to select a test frequency down to every second. There's the version of IP, and up at the top right, we can see traceroute. Let's talk about that. Okay, assuming that we have a bunch of these monitors set up that are running tests against all of our cloud services, let's talk about this trace data I showed earlier, which can be used to visualize a hop-by-hop baseline over time. Here we're looking at an agent in Chicago, Illinois that is monitoring Google Docs. Since these agents perform trace routes, the platform can use the data collected to display the number of connection hops over time as well as the physical distance. The hop-by-hop path at the very bottom is displayed at each interval selected in the above trend. If a problem in the internet path occurs, the routers that are possibly introducing the issues are made obvious. To see the data that makes up this path, you always have access to the raw trace. Now we need to figure out how to avoid the problem area in the cloud. So we have a few options here. First, you might be able to speak with the service provider responsible for the connection and ask them to find a new path for the connections to the targeted SaaS. Second, we can look for an internet exchange point that will allow us to get around the problem area. Perhaps there is a way to peer with the service provider that is hosting the CDN, which supports the application we're trying to speed up. And third can be the most expensive option, where we look for a new service provider to find transit that avoids the problem hop. All right, we've covered a lot of ground. Let's make sure we understand the differences between synthetic monitoring and traffic monitoring. Traffic monitoring tells us how much traffic is going to specific locations. It can be helpful in telling us what apps are consuming the most bandwidth. And they can help us understand when we will reach network capacity. Tools for network monitoring include SNMP, packet capture, and NetFlow. Synthetic monitoring, on the other hand, can tell us what performance will look like if the app is accessed from someplace new. It can tell us if a service provider in a public cloud is no longer available. If you move an application to another cloud vendor, it can tell us what performance will look like. HTTP connections, traceroute, TCP ping, API connections, and more are all used to collect this data. And a network observability platform pulls these two monitoring specialties together. Synthetic monitoring is becoming more popular because latency has become, in a sense, the new outage. Availability of networks and applications has largely been solved. That is, of course, if your company has made the proper investments. When everything is on-prem, latency isn't a problem. Today, almost all traffic is headed to the cloud, which introduces brownouts. Synthetic monitoring allows us to monitor the path through the internet to an application and, if necessary, work around the trouble spots. I like to tell folks that adding bandwidth to a business or a home office to solve a slowness problem is like adding more cowbell to your favorite song. It probably won't improve the melody. To solve the latency problem, synthetic monitoring tells us where we need to commit resources. Okay, hopefully it is becoming obvious in this presentation that synthetic monitors help us find and work around brownouts either within the internet or with cloud services. They allow us to baseline application performance from multiple angles. They allow us to test geographically before rolling out applications. And they give us proof, when needed, that the business is adhering to SLA agreements. Before I wrap up this webinar, I want to share with you 4 ways Kentik monitors cloud services and shares the data with its user community. So to help them gain further insight into how their SaaS applications should be performing for them, Kentik has deployed synthetic monitors all over the world, which test for a multitude of common SaaS applications. Details include DNS response time and average HTTP latency to each one of these apps. This data is shared with our customers in the Kentik Network Observability Cloud. It allows them to compare the performance they are seeing with what Kentik is seeing. Second is cloud performance. This platform also tests inter-cloud communications within the same public cloud for our customers. These meshes represent synthetic monitors spread out in the AWS, Azure, and Google infrastructures, and they are all reaching out to one another in the same cloud to measure performance. These 3 dots right here represent what is being measured. If you click on them, we can see that latency in both directions is above the threshold. All of this data is shared with Kentik customers, again, to compare what they are seeing in a public cloud with what Kentik is seeing in the same cloud. Third is the BGP Route Viewer, which is used to help customers proactively monitor BGP route updates. This BGP Route Viewer allows customers to enter their prefixes and ASNs. The platform will then routinely post BGP data for those prefixes. Then, if, for example, you change service providers, you can be sure that your routes show up here. You can verify that they are being correctly advertised and reachable. This interface can also be used to alert NetOps that someone has hijacked your ASN. And finally, DNS performance. The platform monitors several popular DNS services from over a dozen locations around the world. And again, Kentik makes this view available to our customers. This is also a helpful view as more web browsers implement DNS over HTTPS. All right, let's start wrapping this up. It's important to understand that monitoring cloud services requires first access to synthetic monitors to verify the response time of SaaS applications, hop-by-hop path visibility in order to identify trouble spots deep inside the internet so that you can work around them, and third, a network observability platform that ties it all together. That's all I have, Jordan. Do we have any questions?
Thanks, Michael. That was a great presentation. So let's open up the Q&A panel now. Joining us, we also have Kevin Woods, Head of Product Marketing at Kentik, to help with these questions. So let's see what we have coming in. So the first one is, how much does it cost? Kevin, you want to take that one?
Sure. If you go to our pricing page at kentik.com, you'll see we have a nice page on all of our pricing there. We have the Kentik editions listed, all 3, and the pricing. And we include synthetic test credits, all the things that Michael showed you with each one of those editions.
Gotcha. So you got another one. So in the advanced options, when setting up thresholds, what are the labels for? So Kevin, do you want to take that one again?
Yeah, that's just so that you can tag or put a label on the tests. There can be lots of tests, and you may want to have, your own organization scheme for those so that you can search and find them later.
Got it. Let's see what else. Awesome. So Michael said earlier that the intermittent issues are expected. What can be done to reduce false positives? So Michael, you want to take that one?
Yep, sure. We allow you to set, for example, how many events must occur in a time frame. So, for example, the violation must happen, let's say 5 times within a 10-minute period in order to trigger an alarm. You can specify a restriction on healthy intervals as well. So you can say that if there are 3 intervals where an event didn't occur, then the 10-minute interval timer starts over again.
Got it. Perfect. That's great. So here's the next one. So pinging some targets on the internet could see a significant rate. What would cause this false positives? So Michael, you want to take that one as well?
Yeah, sure. Yeah, if that's occurring, you can increase the number of probes per ping and increase the probability of getting an accurate response. You can also send out TCP pings instead of ICMP, which, well, that could give you better results. And also you can increase the delay between consecutive ping probes to help prevent packet loss due to something like rate limiting on one of the routers in the path.
Awesome. So our next one is, let's see. So do the trace routes use ICMP? So Kevin, would you want to grab that one?
Yes, we also have UDP and TCP to give you a little more realistic measure in a realistic traffic situation. But yes, we use ICMP.
Awesome. So next one is, what is the autonomous system test? So Michael, you want to take that one?
Yeah. Wow. I didn't cover that. These guys are really paying attention. Sorry, I didn't cover that more, but yes, you can monitor by ASN as well. This is a really cool feature because we can use the flow data we are collecting to figure out which ASNs are sending or receiving traffic from your network. And then you can select which agents will test against, say, like Netflix or Akamai. And then every few hours, you can tell the system to automatically grab the most frequent IP addresses for that ASN in case they change, right? So, Kevin, maybe we could talk about ASNs and CDNs, like countries monitoring more in the next webinar. We should think about that.
Yeah, sounds good.
Awesome. And do we have the ability to test by API? Kevin, that sounds like one for you.
Yes, we do have this as a newer capability in the product, and it allows you to specify headers for style sheets and other parameters as well.
Got it. And are there any traceroute tests bidirectional? And how do you do that? So Kevin, can you take that one?
Yeah, so I think you have to think of a test as being sort of one way. If you want to do a bidirectional test, you have to have agents that originate the test on both sides of the link. And that's really easy to set up in Kentik with our autonomous testing. It's really one click and you can set up a bidirectional test with 2 agents and actually display those tests in a mesh format.
Got it. And looks like a next one was, I would like to know what else Kentik Cloud Monitoring can add or improve based on tools the public cloud has already offered.
So we have integrations into public cloud services such as, of course, AWS, Azure, Google Cloud. And within those cloud services, we collect flow logs or flow log equivalents and also some metric data and can display that along with all of the other flow data we show. Synthetic testing, testing for latency, doing pings, trace routes, all of those sorts of things works the same way in cloud for us that it does anywhere else. In particular, we have some tools based on synthetic testing that do cloud performance monitoring. And you can find out more about that at our website. But very generally, cloud, for the Kentik solution, cloud works the same way as it does for on-prem and for internet or for any of the other types of networks that we monitor.
Awesome. That was a great answer. So, it looks like we just about answered everything and we're coming up on time. So, we at Kentik, we appreciate everyone joining us today, and we have covered quite a bit of material. This webinar was recorded, so you can review a replay of it on our website. So that's kentik.com. And please share this with any of your interested colleagues. And you'll get an email from me in the next couple of days, so you can review the content. You'll get a link to the recording and any additional information you'd like. And if you have any further questions, please email us at webinars@kentik.com. Please stay tuned for our next webinar coming up on December 2nd that will be on the evolution of network performance monitoring. So I appreciate you all joining us today, and we look forward to seeing you soon.